Let's roll it back to the very beginning. I designed this robot in Fusion, and here's what the final result looks like. The kind of thing you'd expect to see chasing someone in a sci-fi movie. And of course, I thought, yeah, I can totally build this. Famous last words. So, naturally, I 3D printed the initial leg and base to start the programming challenge. This is where it all began. Getting the robot to twitch, wiggle, and do some very questionable dance moves. I was just making sure everything actually worked. And to my surprise, it did. Kind of. The movements were basic, but they were movements. At that moment, I felt like Dr. Frankenstein. Except instead of lightning, I was running it off a bench power supply. Oh. And because I apparently like making things harder, I slapped some solar panels on it. Did it need solar panels? Absolutely not. Did I want to say my robot was green energy certified? Absolutely yes. Now here's the robot standing, looking impressive, until reality smacked me in the face. This is where I realized everything had gone horribly wrong. It turns out that to make the robot actually move under its own power, I needed way more current. Like, way more. And here's the kicker. There are no PCBs on the market that can deliver 5 volts at over 20 amps, are compact enough to fit inside the robot, and don't look like something you ripped out of a car. This was devastating. I sat there staring at my poor, motionless robot, realizing I had just built a very fancy, very expensive statue. So I made the brave and possibly insane decision. I was going to design my own PCB. But before we dive into that rabbit hole, I want to give you a glimpse of the robot actually moving on its own. And trust me, this did not come easy. It took a ridiculous amount of time, multiple breakdowns, and probably most of my hair. But seeing it finally take those first awkward steps was worth every headache. If you've ever messed around in robotics, you've probably used, or at least seen, the Adafruit PCA9685 board. It's kind of a classic. It lets you control up to 16 PWM servo motors, and it's super easy to use. I built my first custom PCB, capable of delivering 14 amps. Not enough to power a spaceship, but enough to prove my theory. It worked. No sparks, no fire. That's a win in my book. Then came version 2. Cleaner, better, more organized. Still not perfect, but definitely progress. And then came version 3. This one worked beautifully. But there was one problem. It required 3 PCBs stacked on top of each other. It looked like a robot sandwich. Functional, yes. Elegant, number. That's when I had the big idea. Why not combine everything into one board? Genius, right? At the time, I was using a teensy 4.0 microcontroller, which is an absolute powerhouse. But it was running out of space, and I wanted Wi-Fi and Bluetooth built in. Adding extra modules wasn't an option.